I think we finished on this slide. Group 2A ions, or cations, also have 2 dots in their Lewis structure, so they would lose those as an element. It's chemically or electronically neutral, and it would lose the 2 valence electrons when forming compounds, giving it a +2 charge. Pretty straightforward. If you look at this equation that's listed here, magnesium on this side is neutral or 0 charge. Here we have a +2 charge. Here we have 2 electrons, so we end up having the same charges on both sides. They're just broken into 2 pieces. And so magnesium is losing the valence electrons, and since it has 12 electrons and 12 protons, when it loses 2, it becomes +2, and it has the same number of electrons as neon. So here we have the periodic table, just a blow up of group 1A and 2A. And group 1A is kind of in a dark orange, and it is a +1 ion. Group 2A always have the same charge, and they are +2 ions. Now, these are ions that you need to know, all of them, and you need to know how to spell them, and you need to know what their charges are. So, and one that is a tricky spelling is beryllium. It only has 1 R and 2 L's. So that's a little Easter egg for you if you want. I think that's what I'll check for tomorrow when I'm looking at your notes. I want to see the Easter egg I gave you from the first part of this, and this one from the second part. I want to see the word beryllium correctly spelled out in your notes. So transition metals are more difficult. You do have some transition metals that you need to know, and you'll again look at that Quizlet set that I have posted, and it has all of the ions that you need to know and will be tested on. The problem with transition metals is they can do some funky things that they do with their D electrons versus their S electrons, and so they form multiple ions. For instance, iron has 2, Fe2+ and Fe3+, and we would call that iron 2 and iron 3 with Roman numerals to give us the charge on that ion. And it's called the Stock system. You might want to write that in your notes as well, the Stock system. So, how does cesium atom form a cation? So, you would have to look at a periodic table and locate cesium on the periodic table, and that would tell you how many it would gain or lose. You'd have to identify it as a metal or a nonmetal. And so if it's a metal, which this is, it's going to lose electrons. So the answer either is A or C, cannot be B or D. And knowing the column it's in will tell us which one it is. And in fact, it is column 1A, so it would lose 1 electron. How are anions formed? So we've talked a lot about cations. Anions form the same way, except for instead of losing electrons, they're going to gain electrons. So an anion is produced when an atom gains 1 or more valence electrons. And that's how it completes its octet, is by adding electrons and getting to the same electron configuration as the noble gas in that exact row. However, when we name it, we change the ending. So non-metallic elements or nonmetals, we change the ending to IDE. And so when I see IDE, I know that you're telling me it's negative. So chlorine would become chloride. Oxygen would become oxide, even though they do not have the same charge. And nonmetals never have a Roman numeral. That's only for transition metals. So, the nonmetals that you really need to know are listed here. Nitride, phosphide, arsenic, oxygen, sulfur, selenium, trillium, fluorine, chlorine, bromine, iodine. So, Atoms of nonmetal elements obtain a noble gas configuration by gaining electrons rather than losing them, and they end up having a full valence electron shell. So here's chlorine on the left. It has 5 p electrons. It gains 1 more electron to become chloride, and that gives us a full octet. Here we see it in the box diagrams where we have 1 spot available for 1 more electron. When we gain an electron, we now become the same electron configuration of chloride is the same as argon. And that's because it's unusually stable. All halogens have 7 valence electrons. And again, the halogens, when they become ions, are called halides or halide ions. All halogen atoms have 7 valence electrons except for, all of them do. And so they gain 1 electron in each to have a charge of -1. Oxygen is group 6A, so it has 6 valence electrons. It wants to get to 8, so it's going to gain 2 electrons to get to 8. 6 plus 2 gives me 8. And so it gains 2 electrons, and it fills the 2 spots available both here and here. So you have these ions to know. Those are also listed in the Quizlet set that I've given you, and I would suggest you start writing them out because you're not going to remember them unless you do. You will need to know both how to spell and how to write the symbol with the charge. And another little helpful hint is fluoride is often misspelled. It is not fluoride, it's fluoride, F-L-U-O-R. And I get that misspelling quite often. In fact, I'll make that the second thing I'll check for in this video. So, what is the electron configuration of a sulfide ion? What noble gas shares this configuration? So, sulfide is going to gain 2 electrons, and it will be the same as argon. We've gotten to the key concepts. We're almost done. Find the number of valence electrons in an atom simply by looking at its group number, or what I do is I just count over. Positive ions or cations are produced when they lose electrons, and this seems backwards, but we're talking about negative things that we're gaining or losing. So a positive charged ion is a cation, and that's when it loses electrons. An anion is produced when an atom gains 1 or more valence electrons to obtain an octet. So the vocab words are valence electron, electron dot structures, octet rule, halide. So the big idea for this is atoms form positive ions or cations when losing electrons, and negative ions or anions are caused by gaining valence electrons. And we made it to the end. Thanks for listening. I will see you in class.